I'm Lauren. I'm here today with the Cornell Lab of Ornithology. We're not going to be talking about Merlin today. I've heard a lot of people that are excited. They love Merlin. Unfortunately, just so you know, that's not what we're talking about, but hopefully you can get excited about some of our other bird data products. Oh, and I couldn't help but, reference the birds aren't real meme. I'm here to assure you that birds very much are real. There's lots of them. Yes, they're here, and I've spent a lot of time and energy, and I get paid to map them. So just so you know, the birds, they're real. We're going to skip this. You're going to hear the presentation as we do it. Actually, it's been a great primer. Whoever scheduled this today did it perfectly. You can just combine the past 3 presentations, and that's basically what I'm going to be talking about today. But the overview is that we have a bunch of these static maps. We needed to change them into dynamic maps, and then we're going to look at some use cases for how that was actually used in conservation practices. Okay, so what the heck are we even talking about today? So Cornell Lab of Ornithology has a ton of different map products and all kinds of stuff floating out there. The end goal being, let's save birds, right? Let's get people excited about them, let's save them. So to take a step further back, because actually a lot of people in this room might not know, we have this thing called eBird. So people who like to birdwatch, they go out and they submit checklists of those birds, and they tell you what birds they're seeing, how many of those birds that they're seeing, and where they are seeing them. So we have over 1 billion bird observations. We have that data, and the team that I work with, they filter that data, they combine it with a whole bunch of other sources, so land use, land cover, environment, weather, all kinds of stuff, and then it spits out this abundance data. And so we're looking at these static maps that are the result of that, but the underlying data is usually a global raster file. The resolution is approximately 3 square kilometers. So you've got these really tight, densely packed this data, right? So we've got these abundance maps. Thank you, Ian, for talking a bit about migration, so I don't have to describe that. These are migratory species for the most part, so we've got summering and wintering lands on this left map. It shows the sort of yearly overview, and then we also have this broken down into a week-by-week basis, so you can actually see that migration as it's happening. We're going to see if this actually works. It gets kind of angry with me. So we're looking at American robin here. This is going through each week of the year. You can see where it's migrating northward, it's summering or wintering in this area, and hanging out before it migrates back down southward. So we have these maps. Come on, let's go to the next slide. It's trying. So we've got these maps that are showing the when and the where. That's fairly straightforward for map people, right? The how many birds there are is a little bit more complicated, and I could truly do a full 20-minute presentation just on what this relative abundance value means. But for our purposes, we're just going to say that the darker colors on the map means that we predict that there are more birds in that area. So here in Pittsburgh, I think we're looking at American robin again in this example. The dark purple, according to the legend, means that there are 8 times more birds than in this more orangey pink area. So we might not know the exact number, but we can compare and contrast the abundance of these birds, right? So we have these maps. They're great. They're beautiful. What's the problem? These are static map assets. Again, most of us in this room are map people, so you're probably thinking, well, what do people do with this data? How can they use it if they have the static maps? Therein lies the problem. People don't know what to do with this. So when this data came out in 2018, this is how it was formatted on our website. You had the high resolution image data, these maps that I showed you. You could download those. We also had geo packages of the bird ranges. And then if you wanted that underlying data, that 3 square kilometer abundance data, you had to go to our R package and download that data. So here's a screenshot of what that looked like. You've got a pretty basic download page information here. Somebody off the screen in the distance is struggling to download our CRAN package and figure out what the hell is going on, right? So that poor person is, we didn't include them. This is problematic for a number of reasons, right? These PNG static images, they don't actually contain any of the data. It's a representation of the data, but if I'm a researcher, I can't do anything with it. The geo package is just kind of a clunky format in this particular case, and there's not really a lot of useful information because you're just looking at the ranges. And lastly, and most problematically, by having the underlying data only available via R, you're excluding huge swaths of people from being able to access this data or even see if there are any interesting research questions that come out of it, right? You have to have R knowledge, so you have to be programmatically savvy. You have to have some GIS knowledge. And lastly, you have to have a machine that's powerful enough to handle these like really robust and huge raster files. So we want to get this information into the hands of as many people as we can. The more people who know about where these birds are, the more we can direct our conservation efforts and know exactly where to put them, right? So the solution, while somewhat simple, is not always easy to implement. We wanted to convert these static map assets into dynamic and interactive ones. So we didn't want to do this all in one fell swoop. So that is where the project Shorebird Viz comes into play. So in 2020, this was prior to my arrival at the lab, my colleagues put together a grant proposal for us to build a web application to bring this high resolution data on a local scale to shorebird conservationists in the Western Hemisphere. So not only is this project immediately useful for shorebird conservationists in the Western Hemisphere, but it also served as a really great pilot project for us to test the feasibility of converting all of these static map assets into dynamic ones. So for Shorebird Viz, we're looking at about 50-something shorebird species only in the Western Hemisphere, whereas for all of our eBird status and trends abundance maps, we're north of 1,000 this year, and at the beginning of next year, we're going to have around, I think, 2,200 species. So, that's a very vast number of species to be working with without testing it out. So that's what we did. So let's take a look at some of the pros and cons of the static and dynamic maps and what ultimately led to our decision to go down this path. So static maps are not dead. I've talked to plenty of people in the past few days who work exclusively in static maps. They're wonderful for a great number of reasons. These in particular, conservationists, ornithologists, biologists, they really love to throw these bird maps into presentations. It gives a really great overview. But most importantly, you're seeing this high resolution data at the global view because you're not having to interact with it, so you can just spit it all out. In this particular example, you're looking at a grassland species, and on the left, you have got the high-resolution static map. And you can see right off the bat, can you see my mouse? Yes, that roadways are cutting into their breeding habitats. So that is a potential research question or research answer. You can see that right off the bat. Due to technical constraints with vector tiles and WebGL, it can't handle this 3 square kilometer resolution data raw. So we have to aggregate it at this zoomed out view, and you lose that level of granularity. A lot of people were really upset to see this go. It's really hard to take things away from people, right? Like once it's out there, you can't take it away. So people get used to this and they don't want to lose it. But for the purpose of this project, we're looking at local areas. People need to be able to zoom in on the map and see their exact area of interest. I'm going to go through these with more concrete examples, but I really want to emphasize that we wanted to take the technical knowledge out of the equation. You have field biologists, surveyors, potentially farmers, people working with bees and birds and all kinds of things. They might not know how to access this data. And so we wanted to put that data in their hands without needing that knowledge. Of course, as I have been saying, beating a dead horse, they have to get that highly localized data. And they also want to be able to interact with that data in a meaningful way and summarize it. So let's look at this in practice. Today we're going to be looking at the Colorado River Delta, which is in northwest Mexico. In this example, we're looking at the shorebird species whimbrel. And on this left image, this is the static high-resolution image. It's great. It shows you where it is globally. It doesn't tell you much about what's going on in northwest Mexico. So if you convert this into a dynamic map, and in our case we're using Mapbox here, Mapbox GLJS, you can actually zoom into your exact area of interest. This is roughly like 40 square miles. So you can zoom into this area and see exactly what abundance values are going on in this area of interest. Not only can you pan and zoom on the map, but you can also change the base layer. We're looking at birds here. These are natural living beings, right? It's very important to see what kind of landscapes are happening in the area. So you can see mountains, you can see mudflats, you can see the agricultural lands. It was really important for the conservationists to be able to see that satellite base layer. By using vector tiles in this dynamic web map environment, we were also able to actually change the styles of the overlay. So I'm not using the actual app here, but there is an opacity slider, so you can just change the styles as needed to see what's going on underneath the abundance layer. And in this particular case, we're looking at agricultural lands. And last but not least, there were some focus groups that were done prior to my joining this project, in which we talked to shorebird conservationists directly. They said that it was really important for them to be able to figure out the percent of population of a species for a custom area of interest. And so we were able to use the Mapbox Draw package, so you can actually draw an area of interest over top of this abundance layer and return the percent of population for that area. So in this particular example, you can see I think we're looking at western sandpiper here, 15% of the total population of that species is in this 40 square mile area for this week of the year. So think of all of the different things that you can do with that data. And you can draw many different shapes on the map and compare and contrast them directly, right? Because you're getting that percent of the total population. So if you have this data, you know exactly where to concentrate your conservation efforts. So that was great to go through that in kind of the general sense of, hey, dynamic maps are awesome. Like these are the cool things that you can do with them, right? But really excitingly, Shorebird Viz was used by shorebird conservationists to actually do some really cool things. So a little bit about this area, and I'm not an expert, so apologies. Someone please correct me if I get anything wrong. But we're still looking at the Colorado River Delta. It's in northwest Mexico, Baja California. I should have done a zoomed out view. Hello, sorry map people. But this is where the Colorado River drains into Baja California. So this area prior to the 20th century was the confluence of freshwater, brackish water, and saltwater ecosystems. You have these wetland marshes, right? It's incredibly rich biodiversity was there. In the 20th century, a lot of dams were built along the Colorado River, so much of these ecosystems were destroyed, like in Iowa, right? Fortunately, since the 90s, there have been a lot of restoration efforts in this area, so people want to restore these native habitats. But they're not exactly sure where to concentrate these efforts. So in the past decade in particular, a shorebird conservation group has been working in this low-lying estuary, the mudflats area of the Colorado River Delta. So this area, when flooded, becomes a really important nesting habitat for shorebirds, for several different species. They were really concentrated on this eastern side of this estuary. They thought that everything on the western end was just beyond saving. They didn't think that there was anything that they could even do to restore the area there. But a colleague of mine, who's kind of an expert in this area, pulled up Shorebird Viz and said, that's really interesting. For several different species, we're actually seeing quite a bit of activity indicating that birds should be on this western estuary. So what's going on? So he knows this group in this area, and he says, let's send people out and see what the heck is going on. So they do land surveys, they do aerial surveys, and surprise, surprise, the shorebirds are there in droves. There's tons and tons of shorebirds that previously nobody knew that they were actually there and able to use these lands. So because of Shorebird Viz, these restoration efforts are no longer exclusively in this eastern end of the estuary, but they have been expanded to the western end as well. So it's really exciting to see this like real world impact of how this data, it's not just mythical abundance bird data, like it's actually doing good stuff. So not only is it great for finding new potential restoration areas or conservation areas, it also highlighted and emphasized the importance of known shorebird habitats. And so, as I showed in the previous slides, a lot of this land is agricultural land. The farmers on the ground already knew that shorebirds were using this land throughout the year for a few weeks while they were migrating. So they already knew that this was local knowledge, but they weren't sure the extent to which they were using it. So with Shorebird Viz, they're actually able to go in, draw areas of interest around these agricultural lands, and say, wow, for these few weeks in the year, 15% of this species uses these agricultural lands, 10% of these species, 20% of these species. So by enabling them to draw these areas of interest and see that data, they're able to really say, yeah, we knew that these were important. We didn't know how important they were, but now there is potential there for farmers and conservationists to create a mutually beneficial program to both save the shorebirds and make sure that their agricultural lands are doing the agricultural things that they're supposed to do. I'm going to skip over this last example because I don't have a whole lot of time. So Shorebird Viz, we're also not going to do a live demo. Actually, I might be doing better on time than I thought, but we're still just going to breeze through. Okay, so I like to think that Shorebird Viz was a great success. It was used, those are some of the examples that I know about, but other Latin American groups have been using this tool and have really great things to say about it, so we're really excited. But that's for 50-something shorebird species. What about the rest of our assets? What happens to those? Should we keep them static? Should we change them to dynamic? Why not both? Sorry for the 3-pixel image here. We decided we didn't want to take anything away from anybody, but we still wanted to get this information into people's hands. And so I think it was last summer, we changed these, we created a dashboard for people to be able to access this data. And so the default view, you have the dynamic maps, but in this top right corner, you can just click it on and you still have the static map. You can still download all of the static maps, and perhaps more excitingly, you don't have to use the R package to download any of this data anymore. There's a download page here in the upper right corner, and you can just select your file from a list, and wow, it's there on your computer. And so hopefully, people who are naturalists, conservationists, biologists, whatever they're doing, hopefully they can first explore the data to see if there's an interesting story there, and then easily download it and use it. But more excitingly, in my opinion, so before I showed the drawing functionality, not live, but you know that it's there. We will be adding that to this app this fall. And so you will have more download capabilities for these areas of interest that you draw. So hopefully you can draw some really cool conclusions yourself. And you're not restricted to 50 species. You're going to have more than 2,000 species to work with, possibly including whooping crane, I'm not sure. So what's the future of this project? I'm really here to learn from a lot of you all. In particular, we really want to make sure that that higher resolution view is available as you are zoomed out. So if anybody has any ideas for ways to make that happen, let's talk after. I've actually got a little bit of time, but thank you all for hanging out with me today. I'm so happy that this is over with. Apparently we can take one question, yes.
Hi, thanks so much. This is awesome, and I love all of Cornell Lab stuff. Do you guys have a sense of how biased your data are towards population centers and like where people are using eBird?
Yeah, so I am not the data person, but I will tell you that our model data takes a bunch of different things into consideration. And for a great number of birds, they are in areas where nobody is birding, nobody lives there. So we have a lot of different factors that go into the model data. I can send you some resources, but I do not feel super qualified to talk about that at length. But yes, it is accounted for in some capacity. Awesome. Thank you all.